Hola clase! Today we are going to start with the first of the rules of derivations, ones that will allow us to go straight into different kinds of functions and obtain the derivatives. We're going to start with polynomials, and so far you only have one tool, which is derivation by first principles. You've been trying to practice and you've been working with several monomials. Things like this, in which you have a monomial here and you will obtain the derivative function there. So, for example, 4x prime gives me 4 minus 8x prime, the derivative of minus 8x is minus 8. X squared, we did it as an example in a previous video, 2x. 2x squared, that gives me 4x, which happens to be 2 times 2x, and so on and so on. So by now you may be wondering if there is a pattern. Of course, lucky for us, there is. So I need to think, well, how does any monomial, a base monomial, look? So, well, I would always have a coefficient, the base, and the exponent there. So, to get the derivative of that, I could have to, of course, use my derivation by first principles, limit when h tends to 0 of x plus h. So this could be a x plus hn minus a x of n, all that divided by h. Now, this x plus h to the power of n is the expansion of a binomial, and if I do this process, I'm not going to do it, but if you want to go from here, I will have some terms cancelling, and I will know that the derivation of a monomial would be a n x to the power of n minus 1. And this is the pattern I was seeing here. It doesn't matter how it looks, I will always be able to put it there. Of course, when I've got polynomials, which are these different terms expanded, I will just be able to do it one by one, and that's actually going to be something very useful later on. Now, this one looks actually quite limited, but you need to realize there are a lot of things that I actually can write in this form as a monomial, even if they don't look like that. They may not look like it straight away. Of course, if I could do that, yes, well, I could straight into 3 times there, times 2, that would be 6, x, n minus 1, 2. So the derivative of 2x cubed, for example, is 6x squared. Now there are a lot of things that I can use this pattern with. Things like a surd of any kind. Well, I know that a surd is a fractional exponent. Well then, this is the same as this, which happens to look like that. So I know how to do it. If something has that x in the denominator, well, I know how to eliminate it. This is a negative exponent, for example. So again, it looks like this pattern. This pattern follows it here. This is a x something, in this case 1 over n. This is still a x something there. If I've got something that looks like a quotient, something like, let's imagine, I don't know, 4x cubed over x. If I look at that, it may look like something I haven't seen, but I can very easily see that this is just a matter of simplifying, and it turns again into this monomial pattern, this ax to the power of n. If they all follow this rule, then they all follow this derivative rule as well. Now, if all of these examples I can force them into a monomial form, which means I've got a way of getting the derivative, it's important to know that this is not anything new. It's not something I invented. It's just applying first principles, but because I'm going to get to the same pattern every time, if I know the pattern, I can save myself this step. Now, if I combine them in a polynomial, then I simply have to divide each one of the monomials, derivate each one of the monomials to get its derivative and combine them together. For example, let's do something like 4x plus 3x squared, and I want the prime of that. Okay, I know the steps of each one, so I can do each one separately and get the result. So 4x prime, that is 4. 3x squared prime, or the derivative of 3x squared, is 6x. Add them together. This is actually going to be a very useful tool called a sum rule that we are going to see in another video. But before, just remember, if I know the pattern, I don't need to do the steps every time. I can just go apply it, and in the long run that's going to solve me or save me a lot of work, which means I've got more time to actually apply the knowledge. Next step, that's some rule that I mentioned, but so we don't make this video very long, that's going to be cut, and we'll see you in the next video. Thanks for watching.